So what we're going to look at today is Robin Hood hashing, which is an alternative to linear probing, or actually it's more of a variation of linear probing because it's very, very similar when trying to resolve collisions in an open addressing scheme for a hash table. And specifically what Robin Hood hashing does is it keeps track of how far away a given inserted item is from its primary position. Now, a primary position is where we would like to place an item due to its hash value. But in the case of open addressing, because we may have to move something or we may not be able to place something in its primary position because it's already occupied, then we have to put it in another cell. And so if we have to move it over so many places, that's the distance. And so what Robin Hood hashing tries to do is to try to minimize this value, this distance from the primary position. And it tries to do so in such a way that there's no one key that's so much farther away than its primary position than the other keys. And another advantage of Robin Hood hashing is it also doesn't have to use tombstones. The number of items in the hash table will be the maximal number of places that we would necessarily have to check if we are trying to do lookup. That we don't have kind of these dead places that we would necessarily have to pass over if encountered when trying to probe to find a particular value in the hash table. In general, the way that Robin Hood hashing works is that when we insert an item, what we do is we follow the same scheme as linear probing, but we compare what its distance from the primary position would be to the current item that is occupying the space that it wants to be in. And what that key can do is it can evict that other item. What it can do is it can say, my distance is bigger than yours right now. And so it isn't fair that I'm forced to keep marching along to find another place. So what it will do is it will kick out that other value. And so that other value then has to go and find another place. And what ends up happening is that that particular value will go on to the next spot. And if there is something there, then that one has to be shifted over in one spot. So what it ends up doing essentially is shifting all of those items here over by one place while incrementing the distance they are from their primary positions.